Hello everyone. Today I am here with you all with the topic Exponents and Power for class 8th. In this video, we will be learning about the concepts of exponents and power, laws of exponents and some related questions. So let's start with the topic, that is your exponents and power. We all know that if we are going to multiply 2 5 times, like if I am going to say 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 2, I have multiplied 2 5 times, then it could be written as 2 raised to the power 5. Similarly, if I am going to multiply 3 4 times, like 3 multiplied by 3 multiplied by 3 multiplied by 3, so I can write it as 3 raised to the power 4. Similarly, if x is any of the number, any of the real number it is, if it is going to multiply n number of times, n number of times we are multiplying your x, then it could be written as x raised to the power n. This is known as your exponential form. This form is known as exponential form, where x is your base and n is known as your, either we can say it as exponent, or we can say it as index, or we can say it as power. So over here n is the exponent or index or power and x is your base, right? So this x raised to the power n is your exponential form. This could be read as x raised to the power n. We can speak it as x raised to the power n, where x is your base and n is known as, either we can say it as exponent, or we can say it as index, or we can say it as power. So if this we have to write in the exponential form, this is the exponential form, this is the exponential form, and where 3 is the base and 4 is the power or index or your exponent. In this case, 2 is the base and 5 is your exponent or the index or the power. Now we know the expanded form, how to write the expanded form. Suppose I am going to say taking the number 1, 2, 3, 4. So how we can write in the expanded form? This could be written as 1 multiplied by 1000 plus 2 multiplied by 100 plus 3 multiplied by 10 plus 4 multiplied by 1. This is the expanded form of 1234. 1 is going to multiply by 1000, 2 going to multiply by 100, or 3 going to multiply by 10 plus 4 is going to multiply by 1. So this could even be written as 1 multiplied by 10 raised to the power 3. 1000 could be written as 10 raised to the power 3, because 1000 means your 10 multiplied by 10 multiplied by 10. So this could be written as 10 raised to the power 3 plus 2 multiplied by 10 raised to the power 2. 100 could be written as 10 raised to the power 2 plus 3 multiplied by 10 raised to the power 1 plus 4 multiplied by 10 raised to the power 0. 1 could be written as your 10 raised to the power 0. Now we can see over here, if your exponent or the power is decreasing by 1, from 3 to 2, from 2 to 1, from 1 to 0, its value is decreasing by 1/10. From 1000 to your 100. If we are going to divide 1000 by 10, we will be getting 100. If we will be dividing 100 by 10, we will be getting your 10. That means if the exponent is decreasing by 1, from here 10 raised to the power 3, from 3 to 2, 2 to 1, 1 to 0, then the value is decreasing by 1/10. From 1000 it is becoming 100, then from 100 to 10, from 10 to 1, so it is becoming your 1/10. Similarly, one more example we can take. If I am saying 9876.54, then what will be the expanded form of it? Expanded form for this will be 9 multiplied by 1000 plus 8 multiplied by 100, then plus 7 multiplied by 10 plus 6 multiplied by 1 plus 5 multiplied by 10 raised to the power minus 1 plus, or you can say 1 upon 10 even. We can say it as 1 upon 10 even. 5 multiplied by 1 upon 10 even we can say, or we can say 4 multiplied by 1 upon 100. This will be the expanded form for your 9876.54. So how we can write it as 9 multiplied by 10 raised to the power 3 plus 8 multiplied by 10 raised to the power 2 plus 7 multiplied by 10 raised to the power 1 plus 6 multiplied by 10 raised to the power 0 plus 5 multiplied by 10 raised to the power minus 1. 1 upon 10 could be written as 10 raised to the power minus 1 plus 4 multiplied by 10 raised to the power minus 2. So what we can see over here, if the exponent is decreasing by 1 from 3 to 2, 2 to 1, 1 to 0, 0 to minus 1 and minus 1 to minus 2, in every case your value is decreasing by 1 upon 10. Value is decreasing by 1 upon 10. From here 1000 divided by 10 will be your 100, 100 divided by 10 will be your 10, 10 divided by 10 will be your 1, 1 divided by 10 will be 1 upon 10, and 1 upon 10 divided by 10 will be your 1 upon 100. So this is the exponential form, and we can see over here, whensoever the exponent or the power of 10 is decreasing by 1, its value is decreasing by your 1 upon 10. Now let's see some laws of exponents. There are so many laws of exponents are there. We will be learning about all these laws of exponents in this video. So first law, according to the first law, if x raised to the power m multiplied by x raised to the power n is there, then it could be written as x raised to the power m plus n. What does it mean? If there is a base, x is a base over here. If base is there which is same, x over here, base is x here and x here, that means if bases are same and there is multiplication sign in between, and then their powers are going to be added. That means x raised to the power m, m could be any of the number, x raised to the power n, n could be any of the number. If bases are same and there is multiplication sign in between, then powers are going to be added. Like what, we can take an example over here. If I am saying that 2 raised to the power 3 multiplied by 2 raised to the power 4. So it could be written as, bases are same, that is your 2. Over here value of m is your 3, value of n is your 4. So bases are same. So if multiplication sign is there in between, powers are going to be added. So it will be 2 raised to the power 3 plus 4, or we can say 2 raised to the power 7. Now how we can prove it? See, 2 raised to the power 3 means 2 multiplied by 2 multiplied by 2, that is 2 raised to the power 3 only, multiplied by 2 raised to the power 4. So multiplied by 2 raised to the power 4 means this is your 2 raised to the power 3, and now 2 raised to the power 4. This is your 2 raised to the power 4. 2 multiplied by 2 multiplied by 2 multiplied by 2. This is a 2 raised to the power 4. So if we are going to solve it, how many 2's are there? 1, 2, 3, 4, 5, 6, 7 are there. So we can write it as 2 raised to the power 7. So whenever there are bases are same and there is multiplication sign in between, then powers are going to be added. These powers could be any integer. Any of the integer it could be. The power could be any of the integer, and your base could be any real number. Your base could be any real number, and your power could be, or the exponent or the index could be any integer. For all the cases, integer. So in all these cases, your powers are going to be added if your bases are same and there is multiplication sign in between. We can take one more example. If I am going to say 2 raised to the power 3 multiplied by 2 raised to the power minus 2. Here bases are same and multiplication sign is there in between. That means powers are going to be added. So it could be written as 2 raised to the power 3 minus 2, because 3 plus minus 2 I will be doing, that is 3 minus 2 only. So 3 minus 2, it will be your 2 raised to the power 1, or we can say the value will be your 2. So this is how your first law of exponent is. Now let's understand some more laws of exponents. The second law of exponent says, if a raised to the power m divided by a raised to the power n, then it could be written as a raised to the power m minus n, where we are taking that value of m is greater than your n. That means if bases are same and there is division sign in between, then powers are going to be subtracted. Like if I am going to take an example, if it is 5 raised to the power 6 divided by 5 raised to the power 4. Over here 6 is greater than 4. So this could be written as 5 raised to the power 6 minus 4, that is your 5 raised to the power 2. If bases are same and there is division sign in between, then powers or the exponents are going to be subtracted. Now if we are going to solve it, it is 5 raised to the power 6 divided by 5 raised to the power 4. That means 5 raised to the power 6 means 5 is going to multiply 6 times. 5 into 5 into 5 into 5 into 5 into 5 divided by 5 raised to the power 4 means 5 into 5 into 5 into 5. Then we can cancel these. 4 5s are going to cancel, and what is remaining is your 5 raised to the power 2. So this is how we can prove it even, that if bases are same and there is division sign in between, then powers are going to be subtracted. But now if n is greater than m, a raised to the power m divided by a raised to the power n means a raised to the power m upon a raised to the power n. We are saying over here that the value of n is greater than your m. So it could be written as 1 upon a raised to the power n minus m. In the denominator, we will be subtracting the powers because value of n is your greater than your m. Now let's understand this again with an example. The same type of example I am taking. 5 raised to the power 4 divided by 5 raised to the power 6 I am taking over here. Now how we will be writing it? 5 raised to the power 4, over here we can see that in the denominator, power of your base is more than your power of your base in the numerator. In the denominator, power is more. So how we can solve it? 5 raised to the power 4 could be written as 5 into 5 into 5 into 5. 5 raised to the power 4 it is, and in the denominator it is 5 raised to the power 6. So 5 is going to multiply your 6 times. 1 2 3 4 5 and 6 times. Now again we can cancel the 5s. 3 4 5s are cancelled. In the denominator, what is there? 1 upon 5 into 5. That means 1 upon 5 raised to the power 2 over here. And if I'm going to solve it over here, so this could be written as directly using formula. So it will be 1 upon a is your 5, 5 raised to the power 6 minus 4. 6 minus 4, that is 1 upon 5 raised to the power 2. So directly even using formula we can solve it. You're using law of exponent, it will be applying it directly, we can find the value. Now let's see the third law of exponent, that is a raised to the power m whole raised to the power n is there, then its value will be a raised to the power m multiplied by n. It could be written as a raised to the power m multiplied by n. Suppose I am going to say it is your 2 raised to the power 3 whole raised to the power 4 it is. So this will be written as 2 raised to the power 3 multiplied by 4. Powers are going to be multiplied in this case. So it will be 2 raised to the power 3 multiplied by 4, or we can say it will be 2 raised to the power 12. The value will be your 2 raised to the power 12. So if there is any base with any of the power and whole raised to the power some other power is even there, then it could be written as your powers are going to be multiplied. The fourth law of exponent says that if your bases are different and powers are same and there is multiplication sign in between, then we will be multiplying the bases and we will keep the same power which both the bases were having. Like if I am going to take an example again, say first of all we are taking 2 raised to the power, say if it is your 2 multiplied by 3 raised to the power 2. Over here for 2 even and for 3 even, powers are your 2 only. So this could be written as your 2 multiplied by 3, bases are going to be multiplied, whole raised to the power 2. That means 2 multiplied by 3 will be your 6, 6 raised to the power 2, or we can say that its value will be your 36. And now if we will be solving it separately, 2 raised to the power 2 means 4, 3 raised to the power 2 means 3 multiplied by 3, that is your 9, 4 9 is your 36. We can see over here both are same. That means if bases are different and both the bases are having the same powers and there is multiplication sign in between, then we can multiply the bases and we can keep this product. The power of this product will be the same what the individual bases were having. So individual bases were having your power as 2. So first of all we will multiply the bases, that is 2 multiplied by 3, and the power of this product will be your 2. So this is how we can solve this. Again, if your bases are different and they are having the same power and division sign is there in between, then we can divide the bases first, and then whatsoever the quotient will be there, it will be having the same power what both the bases were having. Like if I'm going to say your question is 6 raised to the power say 4 divided by your 3 raised to the power 4. If this is the case, so what we can do is, first of all, we can divide the bases, because over here 6 is having the power 4 and 3 is even having the power 4 and there is division sign in between. So first of all, we will be dividing the bases, and whatsoever the quotient will be there will be having the same power, that is your 4. So it could be your 3 2s are 6. It could be written as 2 raised to the power 4, and 2 raised to the power 4 means your 16. Now let's prove it if we'll be solving it. So what the value will be, 6 raised to the power 4 means 6 multiplied by 6 multiplied by 6 multiplied by 6. And 3 raised to the power 4 means 3 multiplied by 3 multiplied by 3 multiplied by 3. If we are going to cancel, 3 2s are 6, 3 2s are 6, 3 2s are 6, 3 2s are 6. So it will be 2 multiplied by 2 multiplied by 2 multiplied by 2, that is your 2 raised to the power 4. So we can prove it like this even. So if bases are different and though both the bases are having the same power and there is division sign in between, so first of all we can divide the bases and then the quotient will be having the same power. This is how we can write it. Now, if your power is negative for any real number, if your power or the exponent is negative, so what we can do is we can reciprocate the number. Whatsoever the real number is there, we will reciprocate the number and your power will become positive. Over here, what we can say over here is a could even be written as a upon 1. If a upon 1 is having your power minus m, then if we will reciprocate the number from a and 1, if both we are going to reciprocate, it will become your 1 upon a, and in that case your power will become your positive. Minus m will turn to your positive m. Similarly, if in the denominator your power is negative, suppose I am going to say if 1 upon a raised to the power minus m is there, then if again I will be reciprocating it, that means from denominator this a will go in the numerator, then power will become positive. So this could even be written as a raised to the power m, because it was in the denominator, so we have reciprocated it and this will come in the numerator and power will become your positive. Your exponent will become your positive. Here we can see a raised to the power minus m and a raised to the power m, they are your multiplicative inverse. What multiplicative inverse were? If we are going to multiply these two numbers, then your product will be 1. So if we will be multiplying these two, a raised to the power minus m multiplied by a raised to the power m. So just now what we said, a raised to the power minus m could be written as 1 upon a raised to the power m also. If it is having your negative power, then we will be reciprocating the number and power will become positive. So it could be written as 1 upon a raised to the power m multiplied by a raised to the power m. So final value will be your 1. So we can say that a raised to the power minus m and a raised to the power m, both are your multiplicative inverse, because product of these two is coming equivalent to your 1. Now what type of questions could be there? 2 raised to the power minus 3. If this is the question, how we can write this as? It could be written as 1 upon 2 raised to the power 3. If your number is 1 upon 3 raised to the power minus 4, so this could be written as 3 raised to the power 4. From the denominator, 3 will come in the numerator and your power will become positive. Instead of negative, it will become your positive. So if in the numerator we are having the negative index, so we will transfer it to denominator, and if in the denominator we are having the negative index, we will switch it to your numerator and your power will become your positive. From negative, it is going to change to positive. Now let's see some more laws of exponents. If there is any base with the power 0, then its value will be 1. Whatsoever the base we are taking, suppose I am saying 2 raised to the power 0, so value will be your 1. If I am saying your 5 raised to the power 0, its value will be 1. If I am saying 132 raised to the power 0, then its value will be 1. So whatsoever the base we are considering, if power is 0, then its value will be your 1. The next is your nth root of a. If we are writing this radical sign and this way over here we are writing n, that simply means your nth root. Nth root of a. Nth root of a means your a raised to the power 1 upon n. Suppose I am saying fifth root of say 7. That simply means 7 raised to the power 1 upon 5 it will be. If I am going to say third root or the cube root of your say 5 raised to the power 2. So it will be 5 raised to the power 2 whole raised to the power 1 upon 3, because 3 means cube root of 3 means power as your 1 upon 3. It is third root. That means power will be your 1 upon 3. Already in the radical sign there was 5 raised to the power 2 was there. So it will be written as now, just now what we learned is a raised to the power m whole raised to the power n means a raised to the power m multiplied by n. So over here what we will be doing is 2 will be multiplied by your 1 upon 3. So it will be your 2 upon 3. So this could be written as 5 raised to the power 2 upon 3. So if there is nth root of any of the number, then it will be written as a raised to the power 1 upon n. Wheresoever we are using the bases as your a or b, we are considering that they are your non-zero integers. And the powers which we are taking as your m or n, they are any integers, but bases are your non-zero integers that we are considering. We are already taking into consideration that your bases are your non-zero integers or your real numbers. Now the next is, if minus a raised to the power n, then if your value of n, if value of n is your even number, that means if your power or the exponent is even number, then its value will be positive. The final answer will be positive, because we know that negative multiplied by negative is your positive. Like if I am going to say minus 2 raised to the power 4, that simply means minus 2 is going to multiply by 4 times. So minus 2 multiplied by minus 2 multiplied by minus 2 multiplied by minus 2. This minus multiplied by minus will become plus. Plus multiplied by minus will become minus, and again minus multiplied by minus will become plus. So final answer will be 2 into 2 4, 4 into 2 8, 8 into 2 16, plus 16 will be the answer. So if your exponent is your even number, then your final answer will be your positive. Final answer will be positive. That means it will be equivalent to your a raised to the power n only. And if the value of n is odd, that means your power or the exponent is odd, in that case your final answer will be negative. That means value of this will be your final answer will be your negative. That means it will be minus of a raised to the power n. Whatever the value of a raised to the power n will come, along with that value your minus sign will also come if your exponent is your odd number. Like if I am going to take again an example, minus 2 raised to the power 3 I am taking. Over here 3 is your odd number. That simply means minus 2 multiplied by minus 2 multiplied by minus 2. So minus 2 minus multiplied by minus plus, plus multiplied by minus will be your minus. 2 multiplied by 2 is 4, 4 multiplied by 2 is your 8. So final answer will be your negative if your exponent is odd number, and if your exponent or the power is even number, in that case your final answer will be positive. These are the laws of exponents. Now let's see how to write any of the given number in your exponent in your standard form. Like we have already studied, like if we are talking about the mass of the earth or the mass of the moon, or your distance of moon from here, distance of moon from your distance of sun from the earth, if we are taking all these numbers, then it is very big numbers. So suppose this is coming like these, all these are the type of numbers coming. So how to write these type of numbers in standard form? So in a standard form, what we are doing is only one digit we are taking your before decimal. Rest all the numbers will be coming your after decimal. Only one whole part will be taking. Rest all the numbers will be your after the decimal only. So how we can write this as, over here where we have to place the decimal, after 1 we need to place the decimal. If after 1 we need to place the decimal, so how many digits will be there? After that 1 2 3 4 5 6 7 8 9 10 zeros are there, and 1 5 is even there. So 11 digits are there after 1. So what we will be doing is we will be multiplying it by 10 raised to the power 11. We will be dividing it by your 10 raised to the power 11. Now, if we are going to divide this by your 10 raised to the power 11, so what we can write it as, I'm just explaining it to you. 10 zeros are there, so I'm writing 10 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zeros are there. And here in the denominator, there are 11 zeros are there. 10 raised to the power 11 means 11 zeros. Over here, along with the 10 raised to the power 11 is even there. We have converted it into equivalent fraction 10 raised to the power 11. We have multiplied it even and divided it even. So 10 raised to the power 11 could be written as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 zeros. Now 1 0, 2 zeros, 3, 4, 5, 6, 7, 8, 9, 10 zeros cancelled. Now 15 divided by 10 will be your 1.5. That only we wanted. After 1 we want decimal. So it could be written as 1.5 multiplied by your 10 raised to the power 11. So this could be written as, this part could be written as your 1.5 into 10 raised to the power 11. This is the standard form. Now, if we have to convert this into standard form, what we will be doing is, we want decimal after 7. After 7, we want decimal. That means how many digits we have to shift the decimal by? 1, 2, 3, 4, 5, 6. 6. So what we will be doing is, we will be multiplying it by 10 raised to the power 6 and we will be dividing it by 10 raised to the power 6. What we have done is, we have to shift this decimal by 6 digits. 1, 2, 3, 4, 5, 6. After 7, we want your decimal. So we will multiply it by 10 raised to the power 6 and we will divide it by 10 raised to the power 6. Now, if we are going to solve it further, if we will be removing this decimal. So 1, 2, 3, 4, 5, 6 digits are there. So 1, 2, 3, 4, 5, 6 zeros will come in the denominator. So this could be written as 7. I have taken as it is, multiplied by, I am writing it in the expanded form like this: 1, 2, 3, 4, 5, 6. 10 raised to the power 6 was there, so I have written it like this, divided by 1, 2, 3, 4, 5, 6 into, it is again 10 raised to the power 6, so I am writing it as 10 raised to the power 6 only. So here, 1 after 1 there are 6 zeros, after 1 there are 6 zeros, both are going to cancel. So this is your 7 upon 10 raised to the power 6. Just now we said, if it is in the denominator, any of the number is there in the denominator, and we want to take it in the numerator, then the sign of the power will change. Over here, it is 10 raised to the power 6. So if we will take it in the numerator, the power will become your negative. So this could be written as your 7 multiplied by 10 raised to the power minus 6. This positive 6 will change to your negative 6 if we are taking it from the denominator to the numerator. So this is the standard form. So this is how we can write the standard form of any given number. If we have to place the decimal is not there, or we have to shift it, in that case, these are the ways by which we can change the numbers, given numbers, in your standard form. Now let's understand some of the question based on the concept we have learned just now. So question number 1, we have to simplify it. 1 upon 2 raised to the power minus 5. If there is any base with negative power, then we will reciprocate the number and your power will become positive. What we had learned is, if it is a raised to the power m, then it could be written as 1 upon a raised to the power m. So what we will be doing is, we will reciprocate the number. So 1 upon 2 will become your 2 and power will become your positive. That means 2 raised to the power 5. If we want to solve it further, so we can solve it even. The value of 2 raised to the power 5 means 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 2. 5 times we are going to multiply 2. So 2 2s are 4, 2s are 8, 2s are 16 and 2s are 32 will be the answer. The second is 3 raised to the power minus 7 divided by 3 raised to the power minus 10 in the bracket multiplied by 3 raised to the power minus 5. If bases are same and there is division sign in between, then we are going to subtract the powers. A raised to the power m divided by a raised to the power n is your a raised to the power m minus n. So what we will be doing is 3 raised to the power minus 7 minus of minus 10. This will be the value. Over here power was -7, over here power was -10, and we need to subtract the powers. So it will be 3 raised to the power -7 minus minus of 10 multiplied by 3 raised to the power -5. So -7 minus minus will become plus. So it will be -7 plus 10, and -7 plus 10 will be your 3 raised to the power 3. Now it is multiplied by 3 raised to the power -5. Now if bases are same and there is multiplication sign in between, then we are going to add the powers. So it will be your 3 raised to the power 3 plus -5. Plus multiplied by minus will be your minus. So it will be basically 3 minus 5. So it will be 3 raised to the power -2. It will be 3 minus 5 will be your -2. So either we will write it as 3 raised to the power -2, or we can write it as 1 upon 3 raised to the power 2 also. If we want your exponent to be positive, in that case we will reciprocate the number and your power will become positive, or it will be your 1 upon 9. Anyhow, we can write it. Now let's see the third question. 1 upon 2 raised to the power -2 plus 1 upon 3 raised to the power -2 plus 1 upon 4 raised to the power -2. In all the three cases, your power is negative. So we will reciprocate the number so that your power will become positive. So this could be written as 2 raised to the power plus 2. Again, we will reciprocate 1 upon 3, so it will become 3. So 3 raised to the power plus 2. Power will become positive once we will be reciprocating the number. Over here it will be 4 raised to the power plus 2. Now 2 raised to the power 2 means 2 multiplied by 2, 4. 3 multiplied by 3 will be 9, and 4 multiplied by 4 will be your 16. So if we will be solving it further, 16 plus 9 will be your 25. 25 plus 4 will be your 29 will be the answer. Now let's see the next question. Find m if 5 raised to the power m divided by 5 raised to the power -3 is equivalent to 5 raised to the power 5. We know if bases are same and there is division sign in between, then we are going to subtract the powers. A raised to the power m divided by a raised to the power n is a raised to the power m minus n. Over here we can see bases are same. So this could be written as 5 raised to the power m minus, over here power is your -3, so we will write -3. It is equivalent to 5 raised to the power 5. Minus into minus will become plus, so this will be your 5 raised to the power m plus 3 is equivalent to 5 raised to the power 5. Now in the LHS part and in the RHS part, both the parts your base is your 5. So what we will be doing is we will be equating the powers. If bases are same, the powers will even be same only. So we will be equating the powers. It will be m plus 3 is equivalent to 5. And if m plus 3 is 5, so value of m will be 5 minus 3. This plus 3 will go in RHS, will become your negative. And it will be 5 minus 3 is 2. So value of m will be your 2. The next is simplify 25 into t raised to the power -4 divided by 5 raised to the power -3 multiplied by 10 multiplied by t raised to the power -8. Here t is not equivalent to 0. Now we will be factorizing all the numbers. Now 25 could be written as 5 raised to the power 2. 5 into 5 is your 25. So 25 could be written as 5 raised to the power 2 multiplied by, I am writing it as it is for now, t raised to the power -4. Here it is 5 raised to the power -3. 10 could be written as 2 multiplied by your 5. And it is your t raised to the power -8. Now see over here, 5 raised to the power 2 I am writing as it is first of all. Here it is t raised to the power -4, and in the denominator it is t raised to the power -8. Bases are same and there is division sign in between. So powers are going to be subtracted. So it will be t raised to the power -4 minus subtraction sign, we will be subtracting your -8. Here the power of t was -4 and here the power of t is -8. Because division sign is there in between, so we are going to subtract the powers. So -4 minus -8 we had done. Now in the denominator it is 5 raised to the power -3 multiplied by 5 is even there. 5 means 5 raised to the power 1 only. So if bases are same, so multiplication sign is there in between, so powers are going to be added. So it is -3 here Here we are assuming to be 1 because 5 means 5 raised to the power 1. So minus 3 plus 1. The powers will become your 5 raised to the power minus of, okay, I am writing it as minus 3 plus 1. This is your minus 3 and this is your plus 1 we have taken, multiplied by 2. This t we have taken already in the numerator. Now further we will be solving. 5 raised to the power 2 minus 4 minus minus will become plus, minus 4 plus 8. Minus 4 plus 8 will be, again I am writing it as t raised to the power minus 4 plus 8, and in the denominator 5 raised to the power minus 1 minus 3 plus 1 will be your minus of 2 multiplied by your 2. Now here we can see 5 bases are same, division sign is there in between, so powers are going to be subtracted because division sign bases are same, so powers are going to be subtracted. So in the numerator it will be 5 raised to the power 2 minus of 2. This minus 2 we have taken over here because bases were same and there was division sign in between, so we have subtracted the powers. Multiplied by your t raised to the power minus 4 plus 8 will be plus 4 divided by your 2. 2 minus minus will become plus, so 2 plus 2 will become your 4. So it will be 5 raised to the power 4 divided by 2 multiplied by your t raised to the power 4. This will be the solution. We can find the value of 5 raised to the power 4 even. So 5 raised to the power 4 is 5 into 5 is 25 and 25 into 25 will be 625. So this could even be written as your 625 divided by 2 in the numerator t raised to the power 4. This is how we can simplify it. Now the next is find the value of x if 9 multiplied by 3 raised to the power x is equivalent to 27 raised to the power 2x minus 3. So what we will be doing is, first of all, we will be factorizing all these numbers. 9 could be written as 3 raised to the power 2 and it is your 3 raised to the power x. 27 could be written as 3 raised to the power 3 because 3 multiplied by 3 multiplied by 3. 3 3s are 9, 3s are 27. So 27 could be written as your 3 raised to the power 3. So 3 raised to the power 3 whole raised to the power your 2x minus 3. Now here bases are same, powers are going to be added. So it will be 3 raised to the power 2 plus x. Here we have learned that if a raised to the power m whole raised to the power n is there, then powers are going to be multiplied. So we will be multiplying the powers. 3 will be multiplied by your 2x minus 3. This 3 raised to the power 3, this 3 is going to multiply by your 2x minus 3. So it will become 3 2s are 6x minus 3 3s are 9. So 3 raised to the power 6x minus 9. Now in the LHS and in the RHS, bases are same. So when it is possible, when your powers will even be equal. So we will equate the powers. That's why your 2 plus x will be equivalent to 6x minus 9. If we will solve it further, we will take this plus x over here in RHS and this minus 9 in your LHS. So this will be 2 plus 9 equivalent to 6x minus x. Or we can say 9 plus 2 will be 11 is equivalent to 6x minus x will be your 5x. Or we can say value of x is your 11 upon 5 will be the value of your x. This is how we can find it by factorizing whatever the numbers are there. Now the last question, just convert it into standard form. For standard form, what we want is, we want decimal after 1 digit. After 1 digit, we want decimal. That means we will be shifting this decimal your after 8. We want decimal after 8 because before decimal, only 1 digit should be there for your standard form. So how many times we have to shift it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 digits we have to shift it. So what we can do is, either we can multiply it by 10 raised to the power 12 and divide it by 10 raised to the power 12. If we will be multiplying it by 10 raised to the power 12, or we can do, we will remove this decimal and how many zeros will come? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 zeros will come. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 zeros will come. We have removed the decimal. Now 10 raised to the power 12 means after 1 there are 12 zeros are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 zeros and 12 zeros here cancel, only 1 zero will remain. So it will be 85 divided by 10, and here it is 10 raised to the power 12. 85 divided by 10 will be your 8.5, because we want decimal after one digit. So that's the reason we have taken it like this. 85 upon 10 could be written as your 8.5, and this 10 raised to the power 12 in the denominator will be your 10 raised to the power minus 12. So this will be the standard form of your this number. So this is how we can solve the questions using your laws of exponents. Hope it is clear to you. This is all from this chapter. Soon we'll be coming with the more videos on other chapters of class 8 maths curriculum. If you are having any doubt related to maths, please comment me. I'll try to resolve it as early as possible. Thank you.